Good morning, everyone, and good morning, students. Now, today, we will have a new topic, okay? So last time we had done already indices, and we have done already the last topic and today, we will have to start with indices, okay? So indices is chapter 4 of your book. Okay. Okay. Now, if we talk about indices, that will be related to the base of a number and its power. Okay. So to illustrate further, let me share with you our discussions for the day. Okay. Okay. We have here chapter 4 all about indices. Okay. So there you go. So what is an indices or what is an index? What is this topic all about? Okay, will you please read, Akira? Read what is on your screen. Akira? Okay, read. Indices.
Indices.
Okay, shows.
So how many times number is missing
Is being
is being
multiplied. Okay.
multiplied.
Okay, so when we talk about indices, it shows how many times the number is being multiplied. Okay, so if we take it into consideration, if we say a to the power of n, a to the power of n. So when we say a to the power of n there indicates how many times a is being multiplied. Okay, so if we take it, a is considered the base and n is considered the index. Okay, so that means index is also, we could say it is the same as power. Okay. Okay, excuse me. Now, the index there shows how many times a number is being multiplied. It shows how many times the base is being multiplied. Okay, so if to illustrate more, let's take for example 2 to the power of 4. Okay, so when we say 2 to the power of 4, it is just like saying that 2 is multiplied 4 times. Okay, so in this case, 2 is the base. Okay, so 2 is the base and 4 is the index or the power. Okay, so it is just easy to identify the base and the index. So that means now if we say 2 to the power of 4, that is just like saying that 2 is multiplied 4 times. Okay, so that is just the same as saying 2 times 2 times 2 times 2. Okay, so that it is just being written in a shortcut way. And that is having the base and the index. Having the base and the power. So that means 2 to the power of 4 or 2 index 4 would be the same as 2 times 2 times 2 times 2. And that will be the value there equals 16. Okay. 2 times 2 is 4, times 2 is 8, times 2 is 16. So therefore, 2 to the power of 4 equals 16. Okay, now let me assess. Do you understand that in discussion? Bacon? Bacon, do you understand?
Yeah.
Yes, okay. So what about Im? Did you get?
Yes.
Yes, okay. Kim, I want to ask one by one so that I could say that you really understand or not. Kim?
Yes.
Yes. Okay, what about Pi? Pi, do you understand?
I will go to then.
Come again? Do you understand Pi? Yes or no? Yes.
Yes.
Okay, thank you. And what about GJ? GJ, do you understand it? JJ, are you there? Mm-hmm. Okay, if you are not there, okay, I give you warning. Next time, if you are not there when I ask you, then I will remove you from the class. You are just signing in and don't attend. Okay, so Muji, do you understand it? Muji? Muji, are you there? Mm-hmm. What about Chuik?
Yes.
Okay. Akira, do you understand? Not yet. Akira, understand or not yet? Yes, Akira. Okay, a little bit. What about Guy? Did you get it, Guy? Guy. Okay, put, get, understand, put.
Yes.
Okay, Anda, did you get? Anda?
Yes.
Okay, so thank you. I want to assess everyone so that I can make sure that you understood our discussions. Okay, now to show more so that you will fully understand our topic, the indices, the base, and have the power. Okay, now when we talk of -6 raised to a power of 3, meaning the index is 3. It is just like saying -6 times -6 times -6. Okay, now if you take a look, the index shows how many times it is multiplied. So 6 times 6, -6 times -6 times -6. So 3 times. Okay, so the base is 6 and the index or the power is 3. So that -6 times -6 times -6 equals to -216. Now take notice, okay? Take notice of the power, which is odd. Okay? Chuik, what are odd numbers? Give me example of odd numbers. Chuik.
Yes, teacher.
Yes, okay. Well, give me 3 examples of odd numbers. 3 examples.
3 is 4.
Okay, 3 is an odd number. Give me 3 examples of odd numbers.
Okay. 5,
5,
9, 11.
9, and
11.
11. Okay, so when we say odd numbers, it is not divisible by 2 exactly. So that means you will have 0.5 to that if you divide it with 2. So odd numbers, we have 1, 3, 5, 7, 9, 11, 13, 15, 17, and so on. Okay, those are odd numbers. And even numbers, you have, okay, let me ask, give me 3 examples of even numbers. Please unmute.
Yes.
Okay, give me 3 examples of even numbers. Yes, even. Add 1, 3, 5, 7, 9. Now, what is even? And give me 3 examples of even numbers. Yes.
Even number, right?
Yes, even numbers. 3 examples.
2, 4,
2,
6.
4, 6. Okay, so those are even numbers. Now, when we say even numbers, they are divisible by 2 exactly. 2, for example, divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. So those are even numbers. Okay, so please remember that one because that is very important, especially when we have negative base. Okay, that is very important when we have negative base. So even numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on. So those are even numbers. Okay, so I emphasize that one because that is very important in especially with a negative base. Okay, so as the example shows, you have there negative 6 to the power of 3 equals the value negative 216. Now going next, here, negative 7 raised to the power of 4. It is just the same as negative 7 times negative 7, okay, multiplying repeatedly, multiplying the same number repeatedly. So negative 7 times negative 7 times negative 7 times negative 7. So that is negative 7 raised to the power of 4. Okay. Can someone tell me the value of negative 7 raised to the power of 4? Anybody? Who wants to try? Negative 7 times negative 7 times negative 7 times negative 7. Anyone? Put. Chuik, Bacon, JJ. Okay, what about the others? Kim, Im. Okay. So negative 7 raised to the power of 4 equals 2,401. Okay. Now, if you compare negative 6 to the power of 3 and negative 7 to the power of 4. Now, take note that they are having negative base. But here, negative 6 raised to the power of 3, the answer is negative. Okay? And negative 7 raised to the power of 4, the answer is positive. Okay. Here we have the same negative base. Negative 6, negative 7. Both are negative, but the answer is different. Okay? One is negative and the other is positive. Okay, so this is positive 2,401. Now, take note that a negative number raised to a power of an odd number, the answer is negative. Again, a negative base raised to a power of an odd number, the answer is negative. But a negative base raised to a power of an even number, the answer is positive. Okay? So always put that one in mind, that a negative raised to a power of odd number, answer is negative. But if a negative is raised to a power of an even number, the answer is positive. Okay? So please take note of that one. Okay, so as of this time, do you understand the discussion? Do you understand? Okay, Bacon. A negative base raised to a power of 4. What
Base
is the
4.
answer? Positive or negative? Yes.
Base.
Again, a negative base raised to a power of 4. What is the answer? Positive or negative?
Positive.
Positive. Very good. Because, again, negative base raised to a power of even number, the answer is positive. Okay. Negative base raised to a power of 7. What is the answer? Positive or negative? Negative base raised to a power of 7. What is the answer? Positive, negative?
Positive.
7 is
Negative.
negative. Yes, to it. Okay, you can go. Negative. Okay, why? Because a 7 is an odd number and the base is negative number. Okay, so that is very important, especially when you are to give the value or the equivalent of a base raised to a certain power. Okay, so let us continue. Now, what if we multiply numbers raised to a certain power? Okay, as shown in here. Okay, so take a look. The first law of indices, especially in multiplication. When you multiply numbers of the same base, okay, the same base, we follow the rule a raised to the power of n. Again, a raised to the power of m times a raised to the power of n. You maintain and keep the base and add the indices. Okay, again, if they have the same base, keep the base and add the indices, add the index or the power. Okay, so as shown in here, you have here 2 to the power of 3 times 2 to the power of 3. So you have here 2 is the same as 2 times 2 times 2 times 2, and 2 to the power of 4 is the same as 2 times 2 times. So that means it is just equal to 2 raised to a power of 3 plus 4. Okay, so that means you keep the base and add the index. So that means 2 to the power of 7. Okay, again, if the base is the same, all you do is to add the index and keep the base. That is why we have here 2 to the power of 7. Okay, same is true with here. Negative 1 raised to the power of 2 times negative 1 raised to the power of 3. We add the indices and keep the base. So you have now here the answer. 1 raised to the power of 5. Okay, so that is the first law of indices. When you multiply the same base, keep the base and add the index or the powers. Okay, so please understand that one. Please understand that one and do not forget that one. Okay, going next. Here, it is said that in multiplying indices, you keep the base and then add the index. Even if that is, or even if the fraction, okay, even if the index or the indices are fractions, you still add that fraction. Okay, same in here. A is equals to a to the power of m plus n. When you multiply a to the power of m plus a to the power of n. Okay, so please understand that one. Okay, so what if a power is raised to another power? A power raised to another power. Okay, take a look on this example. You have here raised to 3 raised to the power of 4 raised to a power of 2. So you have now 2 powers here, 4 and 2. So what will you do? Okay, so that means 3 to the power of 4 is being squared. Now, if we write it in a multiplication form, that is just the same as 3 to the power of 4 times 3 to the power of 4. That is just the same as x to the power of 2. And that is equivalent to x times x. Okay, again, x to the power of 2 is just the same as multiplying x times x. Okay, so that is just the same with here. 3 to the power of 4 raised to the power of 2 is just the same as multiplying 3 to the power of 4 2 times. So that is why we have here the answer 3 to the power of 8. Because when an index number raised to a power will be multiplied. So that means 2 times 4. Okay? So that is why we have here the answer 3 to the power of 8. So look at here, a raised to the power of m and raised to another power of n is just the same as a raised to the power of m times n. Okay, so please take note of that one, where a is greater than 0, because we have also negative indices. Okay, so negative indices, we will discuss that next. Again, if it is raised to a power, raised to another power, we multiply the powers. Okay, do you get it? We have now 3 important points. 3 important points. Okay, what is indices? What is the value? And then what if we multiply indices? So we add the power. And if we have an index number raised to another power of an index number, then we multiply the powers. Okay? Okay, so as of this time, Bacon, did you get? Bacon?
Yeah.
Yes, okay. Im, get or confused? Yes, okay. Kim, did you get?
Yes.
Yes, okay. Pai, okay. Do you understand? Okay. Chuik,
Yes.
GJ, okay. Guy, Satang, Akira. Okay, so always remember and take notice of the rules in indices. Okay. Next. Okay, here. If we try to practice 2 to the power of 3, okay, I'm giving the answer here so that it will be for purposes of discussion. Now, 2 to the power of 3 times 2 to the power of 7 is we add the power and keeping the base. So that is why it is 2 to the power of 10. Okay? 4 to the power of 7 divided by 4 to the power of 5 is equivalent to 4 raised to the power of 2. Because in division, we minus the power. Multiplication, we add the power. Division, we minus the power. And here, an index number raised to the power of 3 raised to another power of 2, we multiply the power here. So that is why we keep the base and multiply the 2 powers 2 times 3 so that you have here 6. Okay, and that is equivalent to 64 if we find the value. Okay, so those are simple examples, but take note of how it is done. Okay, again, multiplication, same base, add the power. Division, same base, minus the power. A base raised to power and raised to another power, we multiply the power. Okay, so those are part of the laws of indices. Okay. Okay, going next. There is also some special case. Like, for example, this one. 2 to the power of 4 divided by 2 to the power of 4. Now, if we minus the power, take note, we said that in division, the powers are being subtracted. So that is why 2 to the power of 4 divided by 2 to the power of 4 is the same as 2 to the power of 4 minus 4. And 4 minus 4 equals 0. Okay? And we learned in index notation that any number raised to the power of 0 equals 1. That is why we consider this one as a special case. Again, any number raised to the power of 0 equals 1. Why? Now take a look. 2 to the power of 4 written in repeated multiplication, and you have here raised 2 to the power of 4 as the denominator. So we can cancel it out. 2 and 2 and 2 and 2 and 2 and 2. So therefore, that is equivalent to 1. That is a special case. Again, any number raised to a power of 0, the answer is always 1. No matter how small or how big is the number, it is equals to 1. Okay? For example, 120 raised to a power of 0. That is equals to 1. Okay, so please take note of that one. That is a special case. Another here, simplify. Okay, so that is just the same. 2 to the power of 4 divided by 2 to the power of 4. So that is just the same. We minus the power. So that is why we have here 2 raised to the power of 0, which is equivalent to 1. Okay, again, any number raised to the power of 0 equals 1. Okay. Okay. So before we go to our workbook, JJ, are you now there? JJ. Okay, so meaning you are absent. Okay, Kim. Kim, please unmute. Kim. Okay. 15 raised to the power of 1. Again, sorry. 15 raised to the power of 0. What is the answer?
1.
1. Okay, so always take note of that one. Any number raised to the power of 0 equals 1. So that means 15 raised to the power of 0 equals 1. Okay, Chuik. 3 to the power of 2. What is the answer?
9.
9. Put, please unmute. Put negative 2 raised to a power of 3. What is the answer? Put. Oh, where is put? Okay, Bacon. Negative 2 raised to a power of 3. What is the answer?
Equals
negative
8.
Negative 8. Take note. Negative base raised to odd number. The answer is negative. Okay, so I guess you already understand. So please open your workbook to page. Okay, so that page. Again, take out your workbook and open to page 53. Yes. No, page 52. 52 first. Exercise 4.1. Okay, page 52. Open that one and we will answer. Okay, we have 2 minutes left. So I guess we cannot finish. So therefore, you finish the task by yourself. Okay, so page 50. Okay, sorry, 51. 51. Number 1, state the base and the index in each of the following indices. Okay, so you have there 7 to the power of 3. The base is Kim. What is the base? 7 to the power of 3. The base is
7.
7 and the index is
3.
3. Okay, 9 to the power of 5. Bacon. 9 to the power of 5. The base is?
Sure, I don't have book.
Oh, okay. So the base is 9 and the index is 5. Okay, letter C. Letter C, Akira.
Show what
Akira.
page again?
Page 51. Okay, so letter C, Akira. M to the power of 8. The base is, Akira, the base is M and the index or the power is 8. Okay, so we have less than a minute. So please try to answer page 51 to 53. Again, page 51 to 53. Okay, so thank you so much for your participation and for your attendance of today, and see you again on the next meeting. Okay, please try to prepare always your workbook. Okay, so thank you everyone and see you. Thank you, Aim.